Hello, good morning, all. We are excited to present our project data pipeline for TriMet GPS sensor data. We would like to thank first Professor Bruce for this guidance and our TA Alex and Kira for their continuous support throughout this project. I am Jaita and joining me are Kiranmai and Navya. Next one, please. Our project, which focuses on building a real time data pipeline using public transit data from TriMet, the public transportation agency that serves the Portland metropolitan area. TriMet provides a real time GPS data for buses, trains, and stops. In our project, we have built a fully functional pipeline is fully automated, ensuring that data collection and processing continuous daily without manual intervention. Next one, please. In this slide, we present the structure and format for our database and the kind of data we handle. On the top left, we have the DDL for the trip table, including trip ID, vehicle ID, route ID. These fields help us track and organize data collected across different trips. On the top right, we have the DDL for the breadcrumb table. This table captures real-time location data for the buses. Below that, we have shown actual sample data on the bottom left. You can see the sample breadcrumb record from the API. This includes key fields like vehicle ID, GPS location, timestamp, etc. On the bottom right, we show a sample stop event record. This data includes scheduled stop details like location ID, trip number, estimated load, and XY coordinates. This helps us analyze stop level behavior, delays, and crowding. These raw records are parsed and validated and stored into our pipeline. Next one, please. This slide illustrates the complete architecture of our real-time data pipeline for TriMet system. Let me walk through the end of the end-to-end flow. On the left side, we have two public APIs, breadcrumb and stop event. These APIs are accessed daily by our publisher VM, which is hosted in Google Cloud. Inside the publisher VM, we have two Python programs. One is fetches and then next one is publishes. Another that the fetches and publishes stop event data. Each of these records is published individually to a GCP PubSub topic, which acts as our data transport layer for streaming purpose. On the receiving end, we have a separate subscriber VM also in GCP. This enhances the pipeline's reliability. The subscriber VM contains two services, one that subscriber to breadcrumb data and another one subscriber to stop event data. During subscribing, the data is validated, transforms on the fly and loaded into the database. Next slide, please. Here we are showing the backend logic for how our pipeline begins with data fetching and publishing. The first Python script is responsible for collecting breadcrumb data, which includes GPS location of buses. We start by defining logging for debugging and audit, a Google Cloud credentials per PubSub, a list of vehicle IDs. Each one represents a bus in the Trimer system. For each vehicle ID, the script builds the correct API and fetches the data using URL leaf. If the response is valid, it saves the JSON to a file for a backup. Then iterates if over each of the breadcrumb recorded, publish it individually to a PubSub topic. The script uses concurrent.futures to manage publishing all messages asynchronously. At the end, it logs the total number of files, total message sent, and the time taken, etc. The second script also works similarly, but it is designed to fetch the stop event data. This stop event API provides data in HTML. So we use beautiful SOAP API to extract the table data from the page for each vehicle. Then for each unique trip, we parse the HTML and build a structured dictionary and save it to a JSON file. The stop event publisher class also handles success and failure counts and logs them at the end of the traceability. We preserve raw data, publish, and each record independently, keep track of success or failure, and produce logs for debugging. Next one will continue. Me.
Yeah, thank you, Jaita. Hello, everyone. My name is Kiranmai. Now, I want to discuss about next steps in our project, which is subscriber pipeline automation, and the data we processed. Now, I want to discuss about subscriber pipeline. In this pipeline, listens to a PubSub topic called data transport topic sub. It receives real-time GPS records in JSON format for around for 200 vehicles. The data goes through more than 10 validation checks, including checking if all required fields are present or not, timestamps are valid or not, GPS coordinates are within bounds or not. And clean data includes timestamp, latitude, longitude, speed, and trip ID. After a validation, we will do data transformation, which we calculate speed using the formula change in distance divided by the change in time. This is done using group by function and a difference function. We process data in batches of 1,000 messages to improve performance. The first row in each strip has its speed value backfilled to avoid non-values. The clean data is then loaded into PostgreSQL breadcrumb table using copy from method. This copy from method is very fast to insert bulk data. We also implemented logging and auto shutdown service because if data is there was no data for 60 seconds, it will stop. This make it fault tolerant and restartable. Now I want to discuss about stop event subscriber pipeline. This pipeline also subscribes the same topic which we used for breadcrumbs data, but it focuses on trip metadata such as trip ID, vehicle ID, route number, service key, and direction. It checks for all required fields and ensures they are non-null and correct data types and valid data. Then we map these values for clarity, for direction, and service key. A key feature here is deduplication. We only insert each trip ID once using an in-memory cache because in our DDL, our trip table has trip ID has primary key. So if a trip is already loaded, it will be skipped. Clean records are stored in the trip table in PostGRE SQL, again using copy from method for efficiency. Like the breadcrumbs pipeline, this also logs activity and auto shutdown if it is idle for 60 seconds. And next one I want to talk about is pipeline automation. uh, this may to make sure everything runs on its own, we set a timer for the virtual machines so they start automatically each day and in particular given time. We use cron jobs on for the publisher VM to schedule the data fetching and publishing regularly. On the subscriber VM, we use systemmd to keep the subscriber running all the time and restart it if something fails. And now I want to discuss about the data volume data we fetched and published. uh, uh, for this for breadcrumbs data we processed around 600k records per weekday and 400k records per weekend. That over 30 million records total, around 5 GB in size. The breadcrumbs table in PostGRE SQL ended up with 28 million records, taking around 2 GB of size space. For stop events data, we processed around 1300 records per day, totaling around 60,000 records. The final trip table holds near to 55k records, taking just 4.4 MB of size. With this, we can these numbers shows that our pipeline was able to handle large volume of data efficiently with real-time streaming, validation, and database integration. Now, I want Navya. Navya will take over next sections of our project.
Thanks, Kiranmai. Hello, everyone. I'm Navya. So let's take a look at the data visualization. So when you're actually working on the larger data sets, it's always difficult to look at the numbers. So visualization is one good thing where you can little look all of those metrics in graph format. So here, before we approach any of the visualization, the best thing to look at is how clear your data set is, and do you have the concise information on how you want to proceed further on the data set. And similarly, do you have the does your data set have the capability to consistently update the data, like so in order to avoid any biased data. And at the same time, maintaining the data accuracy is super critical when working with the larger data sets or even the smaller ones. And finally, it comes to the compelling conclusion. So, what kind of conclusion are you trying to achieve from this particular data set? So, at least having a rough estimate would help. And let's take a look at couple of visualizations which we have got. First one being, both of these actually talk about Hillsborough City because that's where my entire team is in. So this particular one talks about 6 to 8 p.m. how the traffic is, and we could see the first line where it's super busier. So accordingly, each of us can plan our trips before we could go, and that's what caught our attention. And let's go to the second slide. Yeah, the second visualization, which talks about anything in specific to 1 kilometer radius for Hillsborough Transit Center. So that's where majority of us take the bus from. So it would be easier to understand. Do we even, if we miss any of that stop, then probably we can catch up in the next one based on the direction that we head. So that's something which we would like to know. And let's proceed to the next slide where while we were working on this huge data set, we did have quite a lot of challenges, but we did on the go try addressing those things. And let's look at a couple of those on how we addressed it. So the first challenge being handling this huge data. So even though we were working on other projects, there was never this huge data that we were working real time. So here we had to implement this in-memory processing, which would help us in navigating pretty quicker. And at the same time, when we're trying to write into the database, sometimes we could see the mismatch. So to identify that better, we also had the right fitting assertions, and at the same time improving the logging mechanism. So that helped us a lot. Let's also move to the next slide, which talks about the extra credits that we did. One being implementing this in multiple virtual machines. So one for the publisher logic and one for the subscriber logic. So that really helped us in understanding and processing our data better and on a scheduled basis without any manual intervention. So yeah, that's primarily our project, and thank you all. So beginning with TriMet, so definitely they are the ones who supported by providing the real-time data and enabling many of our data engineers to come into the industry. And at the same time, for having this course organized, I would like to thank Bruce and Alex as well for always being supportive and encouraging us further. Thank you all. Have a good day.